Hi there and welcome to video 9 tutorial. This is a video on volume. As always, these videos are aimed at students who are sitting the Unit 3 AQA higher paper, and in particular hopefully have helped to students who have previously done foundation work and are trying to do the higher. So these videos, I try to make the topics as simple as possible so you can have access to the higher material. As always, during a video, I would like you to make a revision card, at least one, perhaps two, on the topics I talk about in the video. Then straight away move on to video 10, which will be a collection of the past paper exam questions that have come up on volume. So let's start straight away on this topic. What is volume? Well, I'll just draw a quick shape for us. Let's start off with length. Length is how long a line is, or how long something is, something flat is. Okay. Area, then you take it one step further, is how much space a flat 2D shape takes up. Imagine this as being perfectly flat. And volume then is the next level from that. It's how much space a 3D shape takes up. So volume is the space that a 3D object occupies. So, just removing this, the definition you need to know is volume is the amount of space a 3D shape occupies. Now, what are the units of volume? You need to know these. Well, there are many units of volume. Sometimes it depends on the unit we use to measure the lengths in the 3D shape. If we measure the lengths in millimeters, the area would be millimeters squared and the volume would be millimeters cubed. Similarly, if we had measured in centimeters, area centimeters squared, volume centimeters cubed. So some of the common units of volume are millimeters cubed, centimeters cubed, meters cubed, or sometimes straight volume measures like milliliters or liters can be used. Okay, last little bit of talk here. What does the formula booklet give you in terms of volume? Well, it gives you this picture here. It tells you that the volume of a prism is the area of the cross section of that prism multiplied by the length. Now, that actually isn't a prism really mathematically, but let's not worry too much about the definition of a prism, as long as you probably think of a prism as a shape that has the same flat surface no matter how long you go along the length. So if you cut it at any point, it would have the same shape as the face and at the back end, for example. So to work out the volume of any prism, if you could work out the area of the face and multiply it by the length of the shape, or how far back and deep that shape is, that will give you the volume. Okay, using that knowledge of what volume is, the units of volume, and the formula given in the formula booklet, I'm going to move on to some simple volume questions on objects you should be familiar with. Okay, here are four very sort of standard questions that could come up in higher, quite basic. And the question would be, what's the volume of each of these 3D shapes? Well, we know from the formula booklet that the volume of a prism, and all of these are in a way like prisms, apart from maybe this one, but as per the formula booklet, they all look like prisms. You have to work out the area, okay, of the face and multiply it by how far back it is. So in this case here, if we work out the area of the face, it's 4 across and 3 high. So it would be 4 times 3, which is 12 centimeters squared. And we would do, to work out the volume would therefore be 12 multiplied by how far back it goes, which is 2, and we would get 24. Let's get our units right. Because we're using centimeters for length, area is centimeters squared, volume is centimeters cubed, and we're done. Okay, how about this triangular prism? Well, again, we're going to try and work out the area of the front and multiply it by how far back it is. Now, they tell you 12 is the slanted height here. It's a little bit of a red herring, and they tell you 11 is how far back it goes. How do you work out the purple area there? Well, it's actually got nothing to do with this slanted height 12. We don't need that. We know that the area of a triangle is base times height divided by 2. So the area of this is 10 times 9 divided by 2, which will be 45 centimeters squared. So to work out the volume, you simply do 45 multiplied by 11, and you get 495, and the unit, centimeters cubed. Okay, what about this trapezoid? It's got a face that's a trapezium. Okay, now, if you're not sure how to work out this area here, you must look at my videos on trapezium. Okay, that will show you how to work out this area, but it's given in your formula booklet. Okay, so firstly we work out this area here. So area of trapezium. Okay, what you do is you add up the parallel sides, which are 9 and 13. So you do 9 plus 13. Okay, then you half that number, and then you multiply by how far the sides are apart, which is 10. So if you're doing it step by step, you do 9 plus 13 first, which is 22. You half it and get 11, and you multiply by 10, and that gives you 110 centimeters squared. So what's the volume? The volume, therefore, is the cross-section area at the front times by how far back it goes, which is 8. So you do 110 multiplied by 8, and you get 880 centimeters cubed, and you're done. Okay, last one. This is a cylinder here, a cylinder. It works like the formula for a prism, although this technically isn't a prism, it's got curved edges, but let's not worry too much about that. To work out its volume, we work out the area of the face and we multiply it by the depth, or the height in this case. Now the area of a circle, it's got radius, we always write down what a radius is, 10. So we need to know the area of a circle is pi r squared, okay, which will be pi times 10 times 10, pi times 10 times 10. So you type that in your calculator and you get something like 314.16 centimeters squared. To get the volume, you multiply that cross-section area by 18. So you do 314.16 times 18. And you get something like, to the nearest whole number, 5,655 centimeters cubed, which is the volume there. Okay, so we've worked out the volume of very usual 3D objects that come up in the exam. The first one we've got here is a cuboid. Work out the area of that rectangle, multiply it by the depth 2. Here we've got a triangular prism. Work out the area of the triangle, base times height over 2, times it by the depth. Here we've got a trapezoid, a 3D trapezium in a way. You work out the area of the trapezium using the formula in the formula booklet, times it by 8. And a cylinder, work out the area of the circle and then multiply it by 18. And that will get you through a significant number of the volume questions in the higher Unit 3 paper. Just one last thing to point out, 2 other formulas that come up for us in the higher paper. In the front of the book, you will have the volume of a sphere. A sphere is like a football, a perfectly round football, and the volume of a cone. You may be asked in some way or another to apply these formulas. So that tells you here that what you do is you take 4/3, you multiply it by pi, and you multiply it by the radius cubed. The volume of a cone is 1/3 times pi times r squared times h. So let's just make up some numbers here. Let's make the radius in this case, let's make it 4. Let's make the radius here, for the sake of it, 4 again. Let's make this height 10. And let's make this length something like 20, let's say. Okay, let's see if we could work out the volumes of each of these. So we would do on our calculator 4/3 times pi times 4 cubed. The radius here is the key thing. Times 4 times 4 times 4. Now, if you left your answer as a decimal, you would get something like 268. Imagine this was meters, rounded to the nearest whole number, 268 meters cubed. If you left your answer in terms of pi, that is, keep the pi here and multiply everything else together, you would get 256 over 3 pi. Remember, I've told you in a previous video, sometimes in the higher paper they say leave your answers, leave in terms of pi. Okay, so that's the other way of writing it. These two numbers are the same, that would be meters cubed. The volume of the cone here, now the slanted height is not necessary for the volume of the cone. So I've just put that in, that's a red herring. All you need to do is 1/3 times pi times r squared, which is 4 times 4 times 10. Again, you could work that out as a number, okay, and you would get 168, let's call these centimeters this time, centimeters cubed. Or if you left your answer in terms of pi, keep the pi there, multiply everything else together, you would get 160 over 3 pi centimeters cubed. So they're the other two formulas you might need in the exam to work out various formulae. Do remember, they could ask you for half a sphere. Okay, half that, so you would work out the whole sphere and half it, or they could ask you for half a cone or something like that. Okay, thank you for watching this video. Move straight on to video 10, the past paper questions that have come up on volume. Thank you for watching.